Okay, so I just wanted to reiterate what we were doing before the break, just to kind of refresh your memory. So we basically said, look, if we multiply by numbers on the real number line, it basically corresponds to a stretch, okay? And another way of visualizing that, I mean, you know, the way which I visualized it by saying, okay, you're making things longer, you know, by doing that stretch that way that I showed you, is totally fine. Another way to think about it, which I think might make more sense when it comes to thinking about complex numbers multiplication, is to think in terms of this. So basically what I've got here are two number lines. At the moment, these two number lines are completely identical, okay? But I want to show you the effect of multiplying by a particular number when it comes to thinking about these number lines. So at the moment, I'm just multiplying by 1. Hence, these two number lines are exactly the same. But if I multiply by a number other than 1, you can kind of see what happens to the number line. So can you see that the top number line effectively gets that stretch which happens, okay? And the point is I've got those two number lines because the bottom number line is what was there originally, right? The top number line is showing what happens when you stretch or when you multiply by a particular number. So basically all of the numbers just become more and more stretched out. That's the important thing, okay? So let's see what happens when we think about multiplication on the complex plane or the complex or the Argand diagram. Okay, so what I've got on the screen then, again, similar kind of idea. The number on the sort of grid on the left, the complex plane on the left, it kind of is what's happening in relation to the number which we're multiplying by. I'll explain that in a minute. But the crucial thing is what's happening on the right, because that's what's going to actually show what's going on here. Now, before we get there, just remember we said that when we multiply by I, like keep multiplying by I, what happens?
In every 4 steps, it rotates.
Good. So in other words, when we're multiplying by I, so we times by I, we get a rotation which happens. Yeah? When we multiply by any real number, we get a stretch which happens. So that might make a bit more sense when it comes to thinking about these complex numbers. Watch what happens. So at the moment, what I'm proposing is that we're going to multiply by 1 plus I. Okay, so you can see this number 1 plus I. I've drawn it on the screen. Okay, it's 1 unit across, 1 unit up in the imaginary direction. So when I multiply by this 1 plus I look at where 1 is at the moment. Okay, and basically I need to make sure that I move 1 to the position of where 1 plus I is. Okay, so watch what happens.
Can I ask a question?
Of course.
You are multiplying the number of 1 plus I with 1, right?
Okay, so at the moment, yes, that's the way which I want you to think about it. I want you to think about where 1 will end up when we multiply by 1 plus I. Okay, now fairly obviously, what is 1 plus 1 times 1 plus I? Just 1 plus I, isn't it?
Yeah.
1 times anything is just itself. So if I multiply 1 by 1 plus I should end up with 1 plus I.
Yeah.
That's the reason why I want to look at 1, but I want to show you what happens if we think about other numbers in a second.
Yeah,
okay. So think about where 1 will end up when we multiply by 1 plus I. Basically, I need to move 1, which is at the moment at this dot, to the position of 1 plus I, which is that little pink dot at the top there. So fairly obviously, I'm going to have to do a rotation, right?
Yeah.
So let me do my rotation first. So I rotate it. So now 1 is along the same kind of orientation as that 1 plus I. Does that make sense?
Yeah.
Yeah? But clearly I'm not quite there yet. I'm still a little way off. So I'm going to now have to do my stretch, right? So if I do my stretch, now I'm at 1 plus I. So in other words, what I'm trying to show you is that when I multiply by any complex number, there's two things which happen. I still get my stretch, exactly the same as the real numbers, I still get a stretch which happens. The thing is now, because I have this multiplying by a complex number, I also get a rotation which happens as well, okay? So this is just for real numbers, but for complex numbers, I also get a rotation which happens. Now, let me show you this again. So let me reset it back to where it was. My question is, how much do I stretch by and how much do I rotate by? Okay, so have a look.
You stretch by
Go on.
with the real number and rotate with the complex one.
Okay, so you're thinking about 1 plus I and thinking about, okay, how much do I stretch by and how much do I rotate by? You're very, very close. I want an actual number though, so I want a number by what I stretch by and a number what I rotate by. So have a look at the screen again. When I do my rotation, are you happy at the moment I'm on the positive real axis? When I do my rotation, I have to rotate myself so that I'm at the same orientation as 1 plus I. How much have I rotated by then?
Pi by 4.
Good. Why is it pi by 4?
Or 45 degrees, because the x and y axis is the same in trig. We did it earlier. It's
Okay.
It's a quarter of, it's a half of a quadrant, so it's pi by 2
Perfect.
divided by 2, pi by 4.
So in other words, you're thinking about the argument of 1 plus I, right? So yeah, absolutely, no, you're totally fine. 1 plus I, if I write that in mod argument form, let's go for polar form, just for the sake of writing it down. What's the modulus?
Square root of 2.
Square root of 2, perfect. Obviously square root of 1 squared plus 1 squared. Times by the cosine of, and you're right, if I take the tan inverse of 1 divided by 1, yeah, you're totally right, pi by 4 plus I sine of pi by 4, right? So the reason why I rotate, in this case, by pi by 4, is because I literally just rotate by the modulus, the argument rather, of the complex number that I'm multiplying by. Okay, so actually more generally, I'm not going to write pi by 4 here. I'm going to rotate by the argument of whatever complex number I'm multiplying by. Okay? Okay, so hopefully that gives a few clues about what I need to stretch by now, because I'm not quite sitting at my number. So at the moment, I'm just a distance of 1 away from the origin, because I haven't done any stretching at all. Okay, so 1 is 1 away from the origin. When I do my rotate, I'm still 1 away from the origin. So what I need to do is I need to stretch so that I'm now the same distance away from the origin as 1 plus I is. So what am I stretching by?
Modulus.
You got it. Yeah, square root of 2 or modulus of z. So that's it. Okay, that's it. When I multiply by complex numbers, I rotate by the argument of whatever complex number I'm multiplying by, and I stretch by the modulus of whatever complex number I'm multiplying by. Okay? So this is the effect of multiplying by some complex number z.